Laura Hamo. Sounds like the attendance today is quite thin.
Hi, Sud, how are you?
I'm running around like a chicken with her head cut off. But yeah, but that's all right. I got your email, and I'm sorry, I'm not going to be able to discuss the possible grants for at least the next several weeks. It's just a really busy stretch for me right now.
Okay, no problem. It's Catherine.
Anna, will you see if Angel is around? I don't know what happened to Angel or Elise or any of the other folks. Laura, how's your project going?
Yeah, hi to everyone. Well, we've been working on the 3 projects. It's basically one project, but 3 products. So what I'm doing is designing for you guys, for the ones of you who don't know what I'm working about, is a prototype for patients with decompressive craniectomy. And so we are basically designing this prototype for low and middle income countries. It is a prototype to protect the patient's brain and to avoid the trephined syndrome, which is the atmospheric pressure against the brain parenchyma. So we are working on the prototype right now. We have the final draft of the prototype. We are working with the lawyer to write the claims and to produce a provisional patent for the bench to bedside competition, which is on April 17th. We have so far more or less like 20 claims, and the university will support us in the whole process, basically. It has been a whole challenge because we have to describe the product type, but not to be very specific. But also we don't want to be non-specific, right? And so we just want to protect 2 prototypes because there are 2 different designs. There's one design for bifrontal decompressive craniectomies and hemispheric craniectomies. And it looks like our prototype will cost around more or less $15, which is a really good price because other prototypes cost like $400 or even more. Our prototype will be around 15. It is made of plastic and thermoplastic materials. And we are also working, because I said there are 3 products. So the first product is the prototype. The second product is the scoping review. We have conducted a scoping review to look at the literature out there of other prototypes that address the same issue. And we have found 5 documents that also describe like similar prototypes. So we are basically identifying their strengths and weaknesses. And also it has helped us to identify our strengths and weaknesses in our prototype. So we are in the extraction phase. We will finish the extraction of the data by March 17th, and then we will write the results, the discussion section, and then we can therefore submit the scoping review. And then the third product is a qualitative analysis. We will conduct interviews to those patients in Colombia. The IRB, the local IRB, is still reviewing the document. They said that they will have an answer this month. It's a long process here, so we are just waiting for their response, and as soon as we know what they have decided and if they accept it, then we will start the interviews. I don't think we will have those findings for the bench to bedside competition, unfortunately, but yeah, that's the update on my project.
That sounds great.
That's an exciting thing. Have you been to bench to bedside previously, Laura?
Not at all, but we have
Yeah,
had
so
some.
we started by we,
Mhm.
I mean, it was started at the U sometime right around 2011. And
Okay.
and it has gone on after the first cycle or two, it was held in the state capitol building, which is pretty exciting
Yeah.
when it's there. And it's a really energizing activity. There are a lot of students with really good projects, but the level of enthusiasm and with faculty is very high. It's a lot of fun. And then, you know, when the awards come out, that's also fun. We have had through the Center for Global Surgery, we've gotten 2 awards in the past, one for a product that we were never able to produce and commercialize. We got to a point even after our provisional patent where we decided that it was not a thing that was going to be scalable and scalable and saleable, you know, but the thing that made it really good and interesting was learning the process. So even if a prototype turns out not to be a final thing, or it turns out that even though it's the final thing, production and sale turns out to be somehow rate limiting in the place that it needs to be deployed, which was the problem with our MDOT device. We didn't end up having the students who had been working on it, when they finished as students, they needed to go out and get jobs and make money, you know, and then they didn't have time to continue on with it. And the faculty involved left the U. So there are things that can be bottlenecks and things that can turn a project sideways. But this one seems to me, you know, as I've sort of watched you describe it, it seems like it's so straightforward and with so few moving parts and something scalable if production and proof of concept work out well, that, you know, it's nice in its simplicity. I think that's one of the beauties of it, is its straightforward simplicity. So I really am happy that you're going to be presenting this at bench to bedside. And here is a thing that I learned a little bit from Mario Capecchi. Do you know who he is?
Yes, I know him.
Yeah, so Mario likes to talk about it's all about the story. And I think it's really compelling to have a story, even if it's an individual patient, behind the product. And when you are pitching your product or pitching this concept, find a story that's compelling with an possibly an individual patient, and why and how this can change the lives of similar people in that circumstance. I think a lot of products fall flat for lack of stories. And this turns out to be a really important part of it. So, you know, as you're putting together your whole package for bench to bedside and for also future development like investment, if you need investment capital, which you probably will, you know, as you start scaling this, the full package will sort of start with a story.
Yeah, actually, amazing things have happened with this team. They have different abilities, and we have a mechanical engineer from Venezuela. We have a industrial engineer and a biomedical engineer, two biomedical engineers. One of them is Chris Richards. And they have been very involved in this project, and they, even though if this doesn't work, they want to keep working on different projects, and they have different ideas, and we have learned a lot from this process. So basically, let me show you something real quick. Like, for example, one of them has been even testing the prototype in the CMI lab. So we have learned that costs is we do not specify costs based on like whatever we want. Is actually based on many different variables. And so, for example, as you can see in the screen, one of the students tested the prototype with different layers, like and we can see here the degrees of deformation in millimeters and the amount of force we can put into different layers, and that will also specify our costs. It looks like we will use a prototype made of 3 layers that will withstand a amount of force of like a 1 person weight, which is 80 kilograms. That's how much the prototype can resist. And so that also, well, I mean, what I'm saying is that we have to take into account a lot of components and a lot of characteristics from the prototype to specify our costs and our marketing strategy and all of that. So we've learned a lot from this process. We are working on the poster and some videos that we have to send them. And of course, I am happy to share our experience once we've competed in this competition. This is our first time for all of us. Unfortunately, just one of the team members, she is not going to be part of the competition, like physically, because she is in Venezuela. And so she will need to pay for the flight and everything. But well, yeah, she is very involved, and it has been really interesting to see how they have put together this prototype. And we have had some meetings with different neurosurgeons and plastic surgeons, residents, and we have showed them the prototype, and they conclude like, yes, we are definitely going to use something like this in our daily practice. This is very useful in our settings. So this has been very interesting for us.
Yeah, I really love those pictures. And if you can add to that some, if not a clinical picture, at least a picture of a model, you know, an actual human.
Yeah.
That will be compelling and helpful.
Yeah, one of the students 3D printed the shape of the patient's head with different deformities. So we will actually show them in the competition how can you adjust the prototype into different shapes.
That's wonderful.
Thank you.
Laura, have you talked to Dr. Budahowski? He's one of the neuro surgeons here.
No, I cannot recall his
He
last
gave
name.
the medical student talk last month, maybe he gave our journal club as well.
Oh, yeah. I remember him.
Yeah, so he might be a good person to connect with.
Mhm.
to get ideas. He's very interested in neurosurgical care around the world, and he's had a lot of experience, mostly in Africa and in a couple of different settings in Africa, but he might be a useful connection. And Mo, he's one of the people that I need to connect you to. That's on my list.
Okay. Awesome. Yeah.
And I don't know if you know, I don't think you've met Mo Sabai, who's on here, who's in neuro rehab, and may also have some interesting input into what kind of cranioplasty device is useful even while people are doing rehab, because their activity may be a part of what needs to be taken into consideration. I don't know.
Okay. Yeah.
Hi, Laura. I'm curious to know more. I don't know if you shared with us, with this group, any kind of information about your device, but I just saw the graph that you shared with us with the pictures next to it. I apologize if I missed any information you shared before, but if you didn't, I would love to see if you have some other pictures just to gain more sense of what the device looks like and how does it work. Can you elaborate on that?
Sure. Yeah. Let me share my screen. This is not the final design because the engineers have the CAD, the CAD designs, the final designs, they have them. But I can share you these two things. Well, I guess it is important for you to know what the other prototypes looks like. So this is one of the prototypes. It was made in Singapore. All of them, there's a particular characteristic of all of these prototypes, and it is that they have been made on 3D printing materials. They 3D printed all of them, and those prototypes are for are specific to each of the patients. So this was made in Singapore, and it took like 7 days for them to design it. And according to the study, these patients said that it was kind of like uncomfortable for them to use the prototype more than 4 hours a day. And the final follow-up was 8 weeks, but they said it was very, very uncomfortable because of the pressure points, even more in the frontal lobe. And then we have this prototype, which is great because it is very similar to the head like shape, like the anatomy of the patient's head. One of the weaknesses is that, well, first it is made of 3D printing materials, but also if you tested this prototype in other patients' head, maybe it will not fit because it's very specific to that patient. So we have identified 2 weaknesses. First, it is 3D printed, so it takes a lot of time for them to produce the prototype. And second, they have designed it just for one patient. So we are trying to design something that is faster, and that even though it is not specific to that patient, it can be adjustable and it can cover different types of shapes. Then we have this one. This was made at the University of Cambridge. It is also 3D printed. It's a really good prototype as well. This is a type of helmets that are used here in the United States in the hospital. This helmet costs around $400, and one of the problems is that patients don't really like it because of the cosmesis. They don't really like to go outside and use a helmet in the church or the grocery store and so on. So we were trying to create something that would look better, kind of. This is another prototype. They created it in Brazil, and it is made of plaster. It is very uncomfortable as well, and it takes a lot of time, like 1 hour to achieve this. And well, it's difficult because sometimes neurosurgeons do not have a lot of time in the ICUs to cut the material, and to do the whole process. So this is not the final design, but it is something like this. So we have the hemispheric one, and then we have the bifrontal one. Those are two different designs. So the hemispheric one, as you can see, will cover the whole hemispheric, the whole craniectomy side. We will make it with, there are three components. So there is a rigid component that will act as it's the hard component. So if the patient had a trauma, then this rigid component should work for that. There is a semi-solid component that goes underneath with indirect contact with the patient's skin to avoid the pressure points. And then there are some straps surrounding the patient's head. And then basically the bifrontal one is kind of like the same. There is a hard component, a soft component underneath, and then the straps. And one of the characteristics of the two of them is that it is water resistant. So it is easy to use. The patient can wash the prototype very easily. What else? I think those are the main features. This is not the final shape. I can always share it with you. But yeah, that's the concept.
So the new feature that your device will have compared to the pre-existing one is that you have a multi-layer structures that actually fit better the injured part of the head. Is that a fair statement?
Yeah, so the difference between the hemispheric and the bifrontal is that actually, because as you can see in the image, this is just one shape, but there are many different shapes, like patients would look very different. So we are trying to see if the hard component could also be, the word is not adjustable, but it is made of a specific material that you can put in the water, and then you can create the special shape of the patient's head, kind of. So that's one of the challenges. We are trying to see if that will work. If not, we will just use, I think, PLA, which is a plastic.
Okay.
Yeah. I guess one of the most important parts of the prototype, well, everything, but the cushion, the semi-solid or the silicone that goes underneath is very important, because that will avoid what I just said about this specific prototype when the patient said, this is very uncomfortable for us.
We had a lot of those challenges when COVID started and we were making 3D masks, 3D printed masks because of the mask shortage.
Right.
A lot of it was using PLA, and then but also requiring silicone underneath because you couldn't wear those masks for hours or and so it's a real challenge. What are your plans after this is prototyped and you've submitted a provisional patent? Are you planning on doing clinical testing, or is there anybody in your group that's interested in doing clinical testing as a project?
Yeah, well, we have tested the prototypes, different versions of the prototypes with our family members, and it looks like
formally, I mean, like a formal clinical study.
Exactly. Regarding that formal clinical study, the answer is yes. Maybe we will try first with cadavers, like we can go to, like death patients, to see if it causes any pressure points in the in those patients, and then we will go and develop like we will test it in real patients, but we would like to test the prototypes first with deaf people first.
Know if that is an actual valid way of studying that. Because I don't think you can actually, it's, at least in the US, it's straightforward to do testing on cadavers.
Mhm.
And this is where meeting with some of the neurosurgery folks would be useful, because you probably actually don't want to do that. You probably want to move forward with the clinical testing.
Right. Maybe I was thinking about the cadavers because of as I said, the pressure point is something important, and the skin preservation is important as well, and the rate of infections. We don't want to increase the rate of infections in these patients.
And that's why it probably should be studied in living patients, because cadavers don't get infections, and you're gonna have completely different mechanics in cadaveric skin compared to live patients. And it may be that there are specific assessments that need to occur in trying it with a small cohort of live patients, or maybe it's not even uninjured patients, right? It's even just on a voluntary basis. I don't know, but I think that those are some of the questions. So what are you trying to assess usability? Are you trying to assess clinical outcomes? I think that's where, and even having some study design input would be useful. One of the people that we're hiring soon, who'll start at the end of this week, is actually a woman who's finished her MPH and is really interested in global health research and helping us with some of those kinds of projects. She doesn't have any experience with this kind of project, but she can potentially be a person to brainstorm with. And if you're having meetings with neurosurgeons, sort of as you can.
Right. Yeah. Well, the biggest study that they have developed so far is a cohort of 10 patients.
Yeah, exactly. And part of it is just looking and seeing what other devices have used, like what other teams have used for other devices for this indication, the other devices that you shared with us, and seeing what their study design has looked like, because that's probably a good next step. And then moving forward with cohort studies or even RCTs, but there's probably be some intermediate patient usability type studies along with sort of clinical effectiveness.
Right.
So,
it occurs to me that also if you were to work with a neuroradiologist, they do a lot of 3D reconstruction with CT for all kinds of reconstructive activities. And so you could probably build some prototypes of skulls based on actual CT that they already have with different defects. And rather than going with cadavers, you could probably get a pretty good library of what's already available with CT reconstructions. I mean, they do this a lot for different kind of reconstructive surgery, but for reconstructive, and especially as they're designing prosthetics. And this would fall into that sort of category of prosthetics.
Perfect. Yeah, that's a great idea. We actually wanted to use CT measures to look at the like how much does the brain get swollen, because since there are different shapes, one of the neurosurgeons said after 2 weeks of the decompressive craniectomy, then the brain parenchyma starts to actually move to the other side of the midline. So that's important. We really need those measures to kind of like standardize and look at the patterns, and that would be very helpful with the design.
Yeah, that would also help you tell the story, because you could tell the story that this is, you know, for individual patients, this is not a static problem. This is a problem in evolution from the acute situation to different stages in healing, and that your product recognizes and addresses that in these specific ways. And you could actually show that, you know, as the an evolution using radiological models, and how the prototype addresses those needs. You know, I think I might focus on that rather than on the skin specifically, because the skin you can deal with later. But the shape of the protective device, if it needs to have modifications for swelling or changing of shape within an individual patient, you don't want to have to give them multiple protective devices as that evolves over the course of their recovery. So
yeah, and what is interesting about this specific problem, well, at least for me, is that when I talked to the other neurosurgeons in Colombia, and we have also talked to other neurosurgeons in Venezuela, they have never prescribed any type of prototype for this patient. So as I mentioned, in the US, they used the helmets, but in Colombia and other LMICs, there's nothing. They have never designed anything like this, and they have never thought about that. And radiologically, they have seen the maybe I can I think I don't have it, but there are studies and there are scientific papers that have shown that after 24 hours of using, let's say, this plate, then the brain parenchyma will go to its normal shape. So there are different ways to see how it really works. And yeah, it's interesting that there's nothing like this for LMICs. It's not the perfect prototype, of course, and we are still exploring different things, but I guess it's one opportunity to start with.
So can you clarify, where are you planning to basically have your proof of concept? Is it in Latin America or here in the US? Because you mentioned that you started an IRB applications in Colombia, is that right?
Yes, we are planning to test it. Like basically this is focused in Colombian patients mostly.
Okay.
It can be expandable to other countries, of course, in the region, and we are conducting the qualitative research here in Colombia because we want to understand the nature of the problem here in this country.
Okay, so you're not planning anything here in the US?
Well, that's not the primary objective. However,
Right.
it can be expandable. It can be used in other countries if needed, but no, the first option is Colombia and its surroundings.
Okay.
Even
Well,
poorer countries.
I'm asking this because, like Sudha suggested, I think your first point of contact should be neurosurgeon, but also in coordinations with inpatient neuro rehab specialist, because once the surgeon has done their work in intensive care or in some kind of inpatient care, and if it's a TBI or brain tumor surgery or whatever, regardless, they have to be following some kind of rehab program ASAP, because it's just part of the routine. So if you can coordinate with neurosurgeon and some inpatient rehab physiatrist, I think that will be your best way to go.
Yeah, great. And we will also include plastic surgeons, actually, because in some of the institutions here in Colombia, the surgeons in charge of the cranioplasties are actually the plastic surgeons, not just the neurosurgeons. So we want to hear everyone.
Sure.
Yeah.
Excellent.
Thank you. Thank you so much.
So Mo, while we're waiting for Suda to get off the phone, did you hear any more from Paula?
Yes, she actually
Yeah,
just
with
sent me an
Paula.
email when we start this meeting, and we're going to meet sometimes next month, it looks like. Yeah. Thank you.
Yeah, that sounds, I think it'll be a good collaboration. Paula has a network that is vast and deep, and so in terms of pediatric neuro rehab, she knows who there is to know, at least in the Intermountain, but also within the US.
Okay. Yeah, I'm excited to meet with her. Thank you.
Yeah. Pleasure.
Sorry, guys, lots of clinical calls. Kind of juggle too many things. Great. I'll connect with Laura and Mo. I'll connect both of you to Carol Wodowski, just so that you have one more person to connect with. And then, and actually, I was thinking about Dr. Rockwell. I don't know if he's, and I was thinking about him, and he popped on this call, just in terms of, being a plastic surgeon and thinking about plastic reconstructive surgery, if there is input from that standpoint. I think that may be a useful connection too. Angel, it'd be great if you can actually, email and make the connection. I think that would be the best thing to do. And Dr. Rockwell, Laura is working on a device for cranioplasty, and we're brainstorming how to support her next steps. And it might make sense for her and you to maybe connect at a later date, so she can tell you a little bit more about the project, and you can kind of see if you have any advice internally at the U or who else you could talk to about how to even study, clinically evaluate these kinds of devices, which is they've gotten to the prototype stage now. The question is, how do you clinically assess it? And we were thinking about, who from plastic reconstructive surgery might be a useful connection.
From the pediatric point of view, Fazi Siddiqui, does a lot of the surgery with cranial synostosis. He works with the neurosurgeons and has for years. So
I don't know who that is, Catherine. Is that someone here at the U?
Yeah, he is at the U. He's a plastic surgeon, but he does a lot of work with the neurosurgeons in the pediatric population. Brad can tell you more.
Yeah, unfortunately, Fazi's been out for many months with a medical issue.
Okay.
I did not know that. I'm sorry to hear it.
But there's a better person, not a better person, but under the circumstances, a better person who I could connect with. But yeah, Suda, they're all at primaries, so that you wouldn't run into them really.
Yeah, that's probably why I'm like, I know there must be people in this area. I just don't interact with them. But maybe Laura, you can email Dr. Rockwell, and when you're here next month or in a few weeks, really, you can try to connect with some of these folks. Does that sound reasonable? Laura, is that?
Yes.
Okay, great. Thank you, Dr.
Yeah, I can connect with the person that under our current circumstances would be best for cranioplasty.
Yeah. Yeah, and I think it would be if Laura has some prototypes that are available, and maybe there's a group there that can work on that. And this is the kind of, potentially this is the kind of study that we could actually, if we come up with a really good study design, we could trial in multiple settings, depending on what our, what our collaborations can allow, and depending on who if anyone wants to take the lead. So, and kind of go from there.
Perfect.
So,
Yes.
yeah, that's great. Okay. And Dr. Rockwell, what are you doing in Ghana? Are you there for wax or?
At the hospital this week, wax is next week.
Fantastic.
That's in Logo,
Togo.
Lome, Togo. Next week, and in Kumasi, Ghana this week.
That's wonderful. And Dr. Rockwell, Dr. Lewis, our burn director, is very interested in seeing if the Ghanaians are interested in a collaboration, but I haven't heard back from Professor Pius or anyone else after the emails that you and I had sent them last month. But since you're there in person, maybe you can ask them what they think. Because Dr. Lewis is very interested in how to create a burn partnership, especially for her nurses and physical therapists and other members of the team and her fellow, as a way of kind of helping the folks here kind of be immersed in a different environment, and contribute to a different, bigger goal than the constant day-to-day, pushing the rock up the hill that we do. Oh, what happened to my camera? My computer's doing weird things.
Yes.
Anyway, my computer's totally doing weird things. I don't know what's happening. Dr. Faustin from Rwanda is very interested. He's the head of their burn unit at the University Teaching Hospital. But Dr. Lewis was wondering if there was perhaps a chance to either go to Ghana and or Rwanda later this year, as a sort of a way to make those connections.
Yes, I can get an answer quickly.
Yeah, and again, it's no pressure, but if there is an interest, then that might be a useful partnership to support under the
very useful.
So and Angel, just in to kind of go around the room and talk about various projects. Angel, today was match day for you, and you matched at Yale for a prelim year. Is that right? Wonderful. Congratulations.
Yes, thank you.
Fantastic. Congratulations.
Thank you.
Yeah.
I'm very happy. I'm excited to start.
Yeah, to start clinically, that'll be great. And you'll have to come spend some clinical time with all of us here so that you can be ready to go when you get there. Is it general surgery or plastics or?
General surgery, yes.
Yeah, so you'll have to start coming and doing some rounds and getting comfortable with all the patients and all the work.
Yes, definitely. I'm excited.
So we'll have to think about that. Oh my God, I'm just getting like paged left and right about all of my clinical patients. Do you want to talk a little bit about your current projects, Angel, about what you're working on and what needs to get finished up?
Yes, so right now we submitted the abstract about the projects in Cambodia, the MIS project. We submitted an abstract for the for the American College of Surgeons, and we are waiting for results if they accept it or not. And also we submitted the journal to the Journal of Surgical Research. We submitted the project with Mongolia about the breast tumor board. And this project is being reviewed by the editors. So we're just waiting on that one for response so that we can work on the edits and resubmit. I'm sure there are going to be edits. And also on our side from all the co-authors. And then about the projects with transplant, we have I'm still working on the submission for the 2-year report of the grant with Mongolia for transplant. I'm writing remember I was writing a paper about the 2 years of collaborations. I'm still working on that one. I think it's almost ready for submission. I just need to review it with Dr. Rodriguez a couple more times, and I think it will be ready for submission. I'm still struggling to find the best match for a journal to submit the manuscript, because Dr. Rodriguez thinks it's not going to be accepted at transplantation, because by the way, that's another thing. We just had a paper accepted by transplantation, the one of the global census that was started. Well, actually, I started it 5 years ago. Then Fidel worked on it while he was here, and then we finished it just last year and submitted, and that one was accepted. But coming again, talking about the other project with transplant and Mongolia, we need, I need to find another journal, because I spoke with Dr. Rodriguez and he doesn't think this one is going to be accepted there. We thought about submitting it as a brief research report. I thought that it could maybe be accepted like that, but Dr. Rodriguez thinks it's better to submit it as original research, but to another journal. So I saw there's a journal called The Lancet Global Health, and there's a version of this journal that is specific for Asia, so that I think that it could be published there. So that's the one that I'm targeting as my first option. But I would welcome any suggestions for journals for this paper.
And that's for the 1-year report of the partnership, is that right?
Yes, 2-year report of the partnership with the Perth transplant program with Mongolia.
Okay. The other option is World Journal of Surgery. I think that's another.
World Journal of Surgery. Okay.
That's another good option.
Okay.
Yeah. So, other thoughts from anybody else? Cool. Well, strong work on Hell. Lots of good work, and then you all just came back from Cambodia to work on a lot of things there, and at some point we need to, maybe in the next week or two, we should talk about what work is happening there and what outputs are coming out, what needs to be done. I think it seems like there's quite a bit of work that's happening in Cambodia, or with that project. So, do you think, did Leaf go with you, or it was you and Anna?
It was Leaf went the last time. He went in December, and this time it was Anna and me.
Okay. So do you think in the next few weeks you guys can come up with a presentation about that project and update the group on where things are and what needs to be done and what we can work on?
Sure. Yes, of course.
Yeah, I kind of outlined the next steps that need to be happening from like an academic standpoint, so that we can also work on different students or people jumping on to work on various things. And I think for everyone else, if there are other students or trainees that want to work on projects, please have them kind of reach out and connect with this group, and we can. We have a lot of projects and a lot of different things that need to be done. We are looking for manpower.
I actually received an email from one of my colleagues from Mexico. She finished her residency in obstetrics and gynecology, and she is interested in helping in projects related to OBGYN. So in case there are any projects related to that, she would be very interested in that.
Yeah, I think there are some, but I would have to send her over to Dr. Harris and her group. But yeah, I think that sounds good. Okay, great. Well, does anybody else have anything else to discuss? Any other projects they're working on? I won't belabor my Rwanda projects. All of them are on fire right now. So I'll be going there this weekend for the next 2 weeks. And,
It would actually be nice to hear a little bit about what you are doing in Rwanda and what you are planning with the next trip.
Yeah. I can give an interim report after the next few weeks. We're in the process of doing some software development testing next week. And that I need to submit the week after that to the NIH so that I can get funding for the next year. So it's there's a little bit of mad dash this month to try to appease all the folks that need to be involved or funding things. So that's what's happening at the moment. But I just came back from Rwanda after a launch of our UK grant, which builds on this project, on this sort of next levels of this project. But I can share some data about how things are going in the next few weeks once I actually have the data to share.
But it's interesting to hear about what it is you're doing with software development, because I'm not sure all of us know, or at least I don't know, what kind of software you're developing and with whom.
Yeah, I'll go. I've kind of given a little bit of that presentation at some point in the last year, but I can do a sort of an update that sort of goes through what the project's all about and what the software is, and then how we've been working on testing it, because we're like having to create new survey tools and having to create a new process for testing it, and our expected goal is deployment of a completed software in July, August, which is the next marathon. But yes, I'd be happy to share that after I get to April 1st. I just have to survive this month of March. Angel, you've got something else?
Yes, I just wanted to mention that there's an opportunity of research, because I don't know if we could relate this to global surgery, but I think it would be related to innovation, and maybe we could find a way to do something related. But I had the opportunity to meet one of the organizers at the Academic Surgical Congress. Mm-hmm. And we were just talking about ChatGPT. I don't know if you are familiar with that system. And we were wondering how many people would be using that now in academic medicine. And I asked this person if it would be possible to survey the participants of the Academic Surgical Congress, and they are discussing it to say if it would be possible. I still don't have an answer, but that's just a project that it's there. I don't know if anyone, I'm still thinking if there's a way to make that related to global surgery and to integrate, but I'm looking just for ideas. And so that's just something that happened, and I wanted to share in case there's someone who is interested or who has an idea of how we could relate these to our global projects.
Yeah. There's not enough. There's lots of projects. There's just not enough people to work on them. So we need to work on drumming up the interest from the students and residents and fellows who want to work on various projects. So that's what we got to work on, because there's lots of different good things. And Anna and I will work on that. Anna's back from working on all the MIS things. So yeah, we'll think about that. Thank you for that idea. Appreciate it. Okay, well, we'll let everybody get on with their day and on to all other things, and let Dr. Rockwell go to bed. It's probably 11 o'clock there. So
yeah, dinner time.
Dinner time. Okay.
We're 6 hours ahead now with daylight savings time.
Oh, that's right. Yeah. Sounds good. Well, I hope you have a good trip next week, and then to WAC the week after.
Yes. Thank you.
Say hi to our friends, Brad.
Yes, I will, Catherine. Thank you.
Have a great
Okay,
day.
Thank you.
bye-bye.
Congrats again
Bye.
on
Thank you.